All right, in this video, we're going to talk about the origins of the exact value triangles and how we can use them to calculate sine, cos, and tan of some basic angles such as 30 degrees, 60 degrees, and 45 degrees without a calculator, and we get our exact values from that. So you will need to memorize two of these exact value triangles, and I'll talk about how you can derive them. So we'll talk about this triangle first. So this is an equilateral triangle. In an equilateral triangle, all of the angles are the same and they're just 60 degrees each. So you can write that in here. So 60 degrees each, and the side lengths could be anything as long as they're all the same since it's equilateral. So we're just going to have side lengths of 2. Okay, and so now we're going to take this equilateral triangle and we're going to actually split it down the middle in half like this. So when we do this, we'll just focus on one half of that triangle. We know that this becomes a little right angle here. This part becomes a length of 1 because we split that in 2 from the 2. And this side length we can calculate by using Pythagoras. So we'll have c squared is equal to a squared plus b squared. We have 2 squared is equal to 1 squared plus b squared. So then 4 minus 1 is equal to b squared. We get that b is equal to root 3. So that side length will be root 3. This angle is still 60 degrees, and this angle here will be half of 60 degrees, which is 30 degrees. So we get this triangle that's got our 30-degree angle and our 60-degree angle. So now if we wanted to ever do any trig value such as cos of 60 degrees, all we have to do is we look at this exact value triangle, we look at the 60-degree corner, we do adjacent over the hypotenuse, which is just 1 on 2. Okay, if we wanted to do tan of 30 degrees, for example, we'll look at the 30-degree corner, which is this one here. We do opposite on adjacent, which is going to be from this corner, the opposite is 1, the adjacent is the root 3, so we have 1 on root 3. And say, we'll do one more if we wanted to do sine of, we'll say sine of 30 degrees as well. We do the opposite over hypotenuse. From the 30-degree corner, opposite is 1, hypotenuse is 2, so we have 1 on 2. Okay, so this is how you can do some of your exact values with the 30 and 60 degrees. This triangle over here is an isosceles triangle, so really I should have put some lines here. So this is an isosceles triangle. With an isosceles triangle, we have the same side lengths on 2 of the sides, and it will have the same angle, and since this is a right angle down here, these must be 45 degrees. Okay, so again, we're going to choose to have side lengths of 1 and 1. And so then using Pythag, we can calculate this side length just by doing a squared plus b squared is equal to c squared. So 1 squared plus 1 squared is equal to c squared. So root 2 is equal to c. So this side is going to be equal to root 2. Okay, and so now we can do anything we like, cos, sine, or tan for 45 degrees. So we'll just do maybe cos of 45 degrees, which is going to be, we can choose either of the 2 corners, it will be the same. So say we'll choose this corner, we'll do adjacent over hypotenuse, which is just 1 on root 2. Okay, we can do tan of 45 degrees, which will be opposite over adjacent, which again, we can go from this corner or we can go from this corner, it doesn't matter, we'll get 1 on 1. So we'll have 1 on 1, which simplifies to 1. Okay, so this is how you can do, without a calculator, any of your trig values for 30 degrees, 60 degrees, or 45 degrees. Now, one thing that is somehow is important to sometimes remember is this answer, for example, 1 on root 2, could also be written as root 2 on 2. And this one here, 1 on root 3 can be written as root 3 on 3. And this is just done by rationalizing. So if you have a square root on the bottom, so say we'll do 1 on root 2, if you multiply both the top and the bottom by root 2, we'll end up with root 2 on the top and root 2 squared on the bottom, which is just 2. So sometimes you'll see answers written in this form, which is the rationalized form. They are actually equivalent to one another. Okay.